Hello everyone and welcome back again to image processing using Python. So in this tutorial we'll be working on how we can detect edges in an image. So what is edge detection? Edge detection is that we will be detecting and identifying edges, borders of each object and present it in a binary image format. So let's go to the code and let's check how we can do this. So during edge detection we are able to produce binary image. So let's go through some of the statements and then we'll go to the function and I'll explain how this function is performing in the background. So let's see. We are first importing computer vision package OpenCV and it is actually CV2, and we are also importing numerical Python package numpy and denoting it as np. So first of all we'll be reading the input image file. This is the input image file name image3.jpg. imread function is the function which is used to read images, and then we are storing it in image variable, and then we want to show and display the original image to the user, and for that we are using imshow function that is defined in CV2. This is the original image title name, and we can give any title name to this, comma image, the image variable where we have stored our input image. So before we proceed, let me show you what image input image we are working on. Okay, image 3. All right, this is what the input image we are going to perform edge detection. So what we'll be doing is we'll be separating only and we'll be displaying only the borders of each object. So let's see how we can do this. Okay, and this wait key is a function where we ask user to press any key to proceed, and then here we have the primary function which we are using right now is cv2.canny. .canny function performs 4 operations in the background. First of all, it reduces noise, it filters noise from the image. So if any noise is there, then it will be a very disturbed output image. So we have to remove the noise first, and then it performs image gradient intensity. So in this particular function, it is going to find out magnitude and direction gradient of each pixel, and then with this as an input, the third operation will be non-maximum separation, where we will be separating each pixel and discarding each pixel to separate from and to identify that is it edge or not. If any pixel is corresponding and constituting to edge, then it is saved, otherwise it is discarded. If it is not a part of the edge, then we'll be discarding it. So we'll be choosing only those pixels which has role in building edges. Okay, and the last operation is hysteresis thresholding. So this we will be separating those edges where it is required, and we'll be discarding those edges which we don't require. So for that we'll be defining 2 thresholds, low threshold and maximum threshold. So these 2 edges, any edges falling below minimum or low threshold value will be discarded, and any edges will be occurring above the maximum threshold or a high threshold, they will be considered as a sure and real edges. And any edges falling between these 2 range values we will be considering is as classified images, and it is actually connecting, depending on its location, it is connected to the particular object. So this particular operation is also used to identify and sharpen the image and detect its borders. So let's see with an example. So what is the syntax? cv2.canny, it has three input arguments: image variable, the input image variable, and low threshold and high threshold. So here we are taking 50 as a low threshold and 200 as a high threshold, and we are storing it in a canny variable. You can give any variable name here. After that, we will be displaying the resulting image using IAMShow function, and this is the title, a canny edge detection, and another input argument is canny, the image variable, the output image variable where we have performed a canny edge detection. After that, we are waiting for the user to press any key using dot wait key function, and then after, as soon as the user presses that any key, then destroy all windows function will be executed to collapse all the windows. So let's go to build and see what we are getting. Okay, so this is the original image. Okay, all right, I'm pressing one key, so we have got the canny edge detected output of the image. You can see how the borders of the edges of the objects in image have been identified and separated. This you can change, and by changing these threshold values. Suppose I'm taking it as 100. Let's see how it affects. Exit the program, go to build and say execute again. Okay, this is original image, and this is the canny edge detected image. So with this we have included more edges, I hope. So you can do some experiments on this by changing those minimum and maximum threshold values in the canny edge detector. So I hope it is enough to get started for any image processing algorithms. One of them is edge detection, and see you in next tutorials. Thank you.